Welcome to the Deep Dive. Today, we're embarking on a, let's say, unique exploration into the world of AI auditing. If you've ever felt like the rapid pace of artificial intelligence just leaves you with more questions than answers, or maybe you're looking for that clearer path through all the technical jargon to really grasp what's important, well, you're definitely in the right place. We really aim to cut through the noise, and deliver those moments of clarity, those aha moments that make complex topics just click. Our mission today is to pull back the curtain on some pretty critical source material, an actual AI audit review manual. And we're not just, reviewing it. We're going to walk through some really crucial self-assessment questions and some real-world case studies, exploring each one: the question, the options, the correct answer, and maybe most importantly, the foundational reasoning behind it all. Think of us as your guides, helping you pull out the really vital insights.
That's precisely right. And these aren't just, abstract academic exercises. What's really compelling about these scenarios is how they manage to distill quite sophisticated principles, things like AI governance, ethical considerations, security, into practical, understandable situations. By unpacking the why behind each correct answer, you'll gain, I think, invaluable insight into how to critically evaluate AI systems in real-world contexts and really understand their broader implications. It's all about building a robust, sort of practical framework for navigating AI when it's actually in action.
I couldn't agree more. So whether you're maybe prepping for a critical business discussion, or just catching up on the latest in the field, or perhaps you're simply driven by a deep curiosity about how AI is audited and managed responsibly,
Yeah.
this deep dive is really designed to equip you with genuine, well-informed understanding. Ready to begin our exploration?
Let's do it.
Let's dive in. Okay, let's begin our journey by looking at the initial set of questions. These are drawn from the foundational concepts outlined in Chapter 1 of our AI Audit Review Manual. These questions really establish the groundwork, for comprehending the core principles that underpin effective AI governance and auditing. We'll be touching on things like high-level decision-making processes and some of the fundamental challenges AI introduces, like inherent biases and crucial security considerations. All right, our first question poses this scenario. Which of the following describes the primary focus of the Artificial Intelligence AI Steering Committee when developing the overall AI strategy? And your options are: A, authorize the budget for upcoming AI projects; B, provide insight on newly identified risk and opportunities; C, oversee the development and deployment of AI solutions; or D, review the technical details of AI solutions. So take a moment. Think about the distinct role of the steering committee. Are they really hands-on in the day-to-day, or are they setting more of the strategic compass?
Okay. The most accurate answer here, the one that reflects the core function of a body like this, is B. Provide insight on newly identified risk and opportunities. Yeah, when we think about a steering committee, their operational altitude is, well, it's inherently strategic. Their central role isn't just about giving the green light to projects or, managing their daily execution. It's really about making sure that AI initiatives are properly aligned with the organization's big picture strategic objectives, its core values, and importantly, its appetite for risk. They're constantly scanning the horizon, asking things like, what are the transformative benefits AI could unlock for us? And equally important, what are the emerging risks? Ethical dilemmas, unforeseen operational challenges, maybe novel security threats that could pop up from implementing these systems. This strategic oversight, it goes far beyond just approving expenditures. It's about setting a clear vision and strategic guardrails for the whole AI portfolio. They are the guardians, really, of the long-term vision and overall enterprise health concerning AI adoption.
That makes perfect sense. So while the other options, they definitely represent important aspects of managing AI, what makes them sort of secondary to the steering committee's primary focus? Let's take option A, authorize the budget. That's critical, obviously, but you're saying it's more of a consequence.
Exactly. It's a consequence of a prior strategic assessment. The budget usually gets approved after the strategic value, the potential risks, the opportunities of an AI initiative have been thoroughly evaluated and deemed, acceptable within the broader strategy. It's a necessary executive function, sure, but it flows from the strategic direction.
Okay. And option C, oversee development and deployment. That sounds more hands-on, more like project management.
Right. That describes a more granular operational, maybe program management function. The steering committee sets the strategic direction for that oversight, defining the what and the why, but they aren't typically involved in the day-to-day management, the milestones, the execution details. Those responsibilities usually cascade down to the project teams and technical leads.
And D, review technical details. That's way too deep in the weeds for this level.
Absolutely. Far too granular for a strategic committee. That deep dive into models, code, infrastructure, that's firmly for the technical teams, engineers, data scientists, and, maybe specialized auditors. A steering committee trusts that those technical specifics are being handled competently within the strategic framework they've set.
Okay, so the practical implication for you, listening in as someone navigating AI initiatives, perhaps in your own organization, is understanding these distinct roles. Recognizing that strategic, high-level oversight from a steering committee is just fundamental to effective AI governance. Their focus is really on defining the right direction and understanding the broader purpose of AI initiatives, making sure AI serves as a true strategic asset, not just, a collection of cool tech projects. All right, moving on to a topic that just continues to dominate discussions around AI bias. Our next question asks, which of the following types of bias would explain an artificial intelligence, AI solution, showing signs of discrimination based on gender in decision-making? And your choices are A, systemic, B, statistical, C, human, or D, overfitting. So when an AI system starts showing discrimination, where's the most fundamental place we should look for the origin of that issue within the system itself?
Okay, the answer that most accurately describes the root cause in this kind of context is A, systemic bias.
Right.
To connect this to the broader landscape of AI, systemic bias refers to those biases that are deeply embedded within the underlying procedures, the structural elements, or maybe most commonly, the inherent biases present in the training data that AI systems learn from. Imagine an AI being trained on vast historical data sets where maybe certain genders were consistently overrepresented in leadership roles, or perhaps historically treated differently in, say, credit applications. The AI, in its fundamental quest to just identify patterns and make predictions, will absorb these historical disparities. And without specific proactive mitigation strategies, it will inevitably perpetuate those patterns in its own decision-making. That leads to discriminatory outcomes against specific social groups, like in the gender discrimination example mentioned. It's not simply a coding error, it's really a reflection of biases that existed in the real-world data or processes that the AI was taught. It's a foundational issue, deep within the system's learning environment.
That brings up a really compelling point. I think many people might intuitively jump to human bias, right, as the direct answer. Since humans are involved in creating these systems and the data, what's the key distinction there?
That's a great question. While human bias, option C, undeniably contributes to systemic bias, it's often the source, right? The source of the initial biases that find their way into recorded data or organizational processes. It's not the direct type of bias the AI solution itself exhibits. Human biases are kind of the inputs that create the systemic bias within the data, which the AI then learns from and replicates. So the AI manifests a learned systemic bias rather than having its own inherent human biases.
Okay, so it learns the bias that was already there. What about statistical bias, option B?
Statistical bias really describes the observable effect, the numerical evidence of discrimination in the AI's output. It's the symptom you detect, like an uneven distribution of outcomes based on demographics. But it doesn't explain the underlying type or cause of that bias.
It's the symptom, not the disease itself.
Got it. And overfitting, D. Yeah, overfitting describes a different technical problem. It happens when an AI model performs exceptionally well on its training data, but then poorly on new unseen data because it's essentially just memorized the training examples instead of learning general patterns. While overfitting can sometimes make issues worse, it doesn't primarily explain the fundamental nature of discrimination based on gender. That usually stems from the underlying data itself.
This really clarifies the issue. If the data fed into an AI reflects societal biases or historical inequities, the AI will internalize and often, worryingly, amplify them. It perpetuates discriminatory outcomes, sometimes at a huge scale. This insight is just crucial for anyone involved in AI. It underscores that the problem often starts long before the first line of code is written, deep within the data sets and the human processes that shape them. Understanding this distinction is, well, it's absolutely vital for developing effective ways to fix it. Yeah. Okay, our final question for this first chapter pivots to a really critical area, security. The question is, which of the following would an IS auditor most likely recommend to enhance threat detection related to an artificial intelligence AI solution? Your options: A, focus monitoring efforts on the AI solution during operation; B, review threat assessment during AI solution development and deployment; C, increasing monitoring across all connected systems; or D, report on emerging external threat actors relevant to the AI solution. When you consider how modern AI systems are so interconnected, within an organization's broader digital landscape, what approach offers the most robust and comprehensive security posture.
The recommendation that really provides the most comprehensive and effective enhancement to threat detection is C, increasing monitoring across all connected systems. Yeah, this point is absolutely essential because AI solutions, they almost never operate in isolation. They're not these contained black boxes. Instead, they are deeply intertwined with a whole multitude of other systems. They ingest data from various sources, they interact with different applications, rely on diverse network components, often integrate with cloud services. It's complex. So, to truly strengthen threat detection, you absolutely need a holistic perspective that encompasses the entire attack surface of this whole ecosystem. By monitoring all connected systems, not just the AI model itself, you ensure that any potential entry points, data flows, interdependencies, or even adjacent systems that an attacker might try to exploit are fully accounted for. This holistic approach provides a much more comprehensive and proactive risk management strategy for the AI's entire operational environment. It's about securing the whole chain, really, not just focusing on one single link.
That makes perfect sense. Like a narrow focus, no matter how diligent you are, inevitably leaves critical blind spots for attackers to find, right?
Exactly.
So what makes the other options less optimal for enhancing threat detection in that complete sense? Let's look at A, focus monitoring during operation. That sounds important, but maybe limited.
It is important, absolutely, for ongoing operational security, but its scope is limited. Threats can emerge earlier, maybe during development, or through vulnerabilities in systems connected to the AI. It's a necessary step, sure, but it's insufficient on its own for truly comprehensive detection.
Okay. And B, review threat assessment during development and deployment. That seems crucial for prevention.
Undeniably critical for embedding security from the start. It focuses on prevention and secure design, identifying and mitigating risks early in the life cycle. But the question specifically asks about enhancing threat detection, which is an ongoing, continuous process. It spans the full life cycle and the integrated environment, not just a one-time review at specific phases.
Right, detection is ongoing.
Yeah.
And D, reporting on emerging external threat actors. That sounds like threat intel.
Exactly. It provides extremely valuable intelligence. It helps organizations understand the evolving threat landscape and what kind of attacks to anticipate. However, it serves as crucial input for defining and refining your threat detection strategy rather than being the detection mechanism itself. It tells you what to look for, but not how broadly or where to implement your detection capabilities.
Okay, so the core message for you here is clear. AI security extends far, far beyond the AI model itself. It encompasses the entire complex network and ecosystem that the AI interacts with. Think of it like, I don't know, securing a modern smart home. You don't just secure the front door. You secure all the windows, the back entrances, all the connected devices, maybe even the surrounding perimeter. For AI, this just means a holistic, system-wide approach to monitoring and defense. Okay, now let's apply these foundational concepts to a more real-world scenario. Imagine FiberCorp. They're a national telecommunications provider experiencing phenomenal rapid growth, which sounds fantastic, right?
Sounds great.
But it's also created a significant bottleneck in their customer service operations, specifically in managing the sheer volume of incoming calls, installation requests, service queries. You get the picture. So in response, the CEO proposes implementing a chatbot to manage those initial incoming requests. This is a highly common and, I think, relatable challenge in today's fast-paced business landscape as companies look for greater efficiency and hopefully improved customer experiences. So our first question regarding FiberCorp is, which types of AI solutions should FiberCorp consider for the proposed business problem? Your choices are A, limited memory, B, reactive machines, C, artificial general intelligence, or D, artificial narrow intelligence. When you think about the specific requirements of a chatbot, its need to hold a coherent conversation, and remember past interactions within that session, which of these categories best describes that essential capability?
The most appropriate answer here, I'd say, is A, limited memory. Yeah, chatbots are a quintessential example of limited memory AI systems. These systems possess two key types of memory. There's a static memory, which holds their core knowledge base from training data, and then there's a dynamic, sort of temporary memory. This dynamic memory lets them retain information from recent interactions or observed data within a specific conversational session. And this capability is precisely what FiberCorp needs for a functional customer service chatbot one that can understand context, follow the thread of an ongoing dialogue, and provide more relevant, helpful responses throughout a customer interaction. Now, while a chatbot definitely falls under the broader umbrella of artificial narrow intelligence, meaning it's designed for a specific task, the key capability that lets it hold a conversation and manage dialogues is its limited memory. It's a specific functional type of AI within that broader A&I category, enabling it to retain context within a session.
Okay, that clarification on limited memory within narrow AI is really helpful. So why are the other options less suitable for a customer service chatbot like this? Reactive machines, B.
Reactive machines, they represent the most basic form of AI. They only react to immediate inputs. They have no ability to store information or learn from past interactions. Think of a thermostat just reacting to temperature changes. It has zero memory of previous settings or user preferences. This fundamental lack of memory just makes them entirely insufficient for a conversational chatbot that needs context.
Right, no memory, no conversation. And C, artificial general intelligence. That's the sci-fi stuff,
Pretty
right?
much, yeah. AGI is a theoretical concept referring to AI with human-level cognitive abilities, understanding, learning, applying intelligence across a huge range of tasks, just like a human.
Huh?
We are still many years, maybe decades, away from achieving true AGI, and it would be vastly over-engineered, completely unnecessary for a specific application like a customer service chatbot.
Okay, definitely overkill. And D, artificial narrow intelligence. You said the chatbot is a type of this.
It is, technically. A chatbot is a form of narrow AI designed for a specific domain. However, limited memory, A, offers a much more precise and descriptive characterization of the specific functional architecture that enables sophisticated chatbot capabilities. It describes how it performs its task, not just what its general scope is.
Okay, so FiberCort's customer service manager is building the business case for this chatbot. And this means a thorough analysis of potential risks is absolutely essential, not just the shiny benefits. Based on what we understand about AI deployments, what are some of the significant potential risks that come with implementing this AI solution? This is multiple choice, so let's explore it a bit.
Yeah, when considering a chatbot for customer service, especially in a large enterprise like FiberCorp, there are several crucial risks to really acknowledge and plan for. First, potential integration challenges. The chatbot won't operate in a vacuum, right? It needs deep integration with FiberCore's existing CRM system, maybe billing platforms, other operational databases. If these integrations aren't designed with really robust security protocols and proper data governance, there's a significant risk of, well, unintended exposure of sensitive customer information. That could lead to serious data privacy breaches, compliance violations. For a telecom company, that would be disastrous.
Huge reputational hit, too.
Absolutely. Second, challenges with training data quality. The chatbot's effectiveness hinges entirely on the data it's trained on. It needs vast amounts of historical customer service data, past call transcripts, chat logs, service requests. If this data is incomplete, maybe indistinct, contains errors, or reflects existing human biases, maybe past agents unknowingly handled certain groups differently, the chatbot will learn from these flaws. This could lead to it generating difficult, erroneous, or even biased responses, ultimately undermining its usefulness and just frustrating customers.
Garbage in, garbage out, essentially.
Precisely. And third, reputational damage. Customer perception of AI service is, well, it's a diverse landscape, and expectations are often quite high. If the chatbot performs poorly, if it's unhelpful, gets stuck in loops, fails to understand complex issues, or simply makes too many mistakes, it could lead to widespread customer dissatisfaction, a flood of complaints, and significant damage to FiberCore's brand reputation. Especially for a telecom provider where service reliability and responsiveness are key to customer loyalty, negative experiences with the AI could directly impact customer retention and market standing.
Wow, that painted a very clear picture of the potential pitfalls. It really underscores that deploying an AI solution like this isn't just about getting the bot to work. It's about meticulously considering how it interacts with existing systems, the quality and integrity of its learning material, and the profound real-world impact on customer trust and the company's brand image. This level of foresight is just vital for you, the listener, to consider whenever a new AI solution, especially one directly facing customers, is on the table. Now let's flip the coin. What are the compelling potential benefits of implementing this AI solution for FiberCore, specifically addressing their customer service bottlenecks? Your options: A, reduced response times; B, improved employee engagement; C, scalability of the solution; D, cost savings. Thinking about FiberCore's core problem, those bottlenecks and the inherent advantages of automation, which of these align most strongly?
Well, in this scenario, I'd say all four options are indeed highly probable and significant potential benefits for FiberCorp. This looks like an all of the above situation.
Okay, so let's break them down. A, reduced response times.
Yeah, that's often one of the most immediate and tangible advantages. Chatbots can handle numerous routine queries simultaneously, respond instantly. It dramatically cuts down customer wait times for common issues and significantly improves the overall efficiency of service delivery.
Makes sense. B, improved employee engagement. That's interesting.
It is. By automating those repetitive, maybe low-value routine queries, the chatbot frees up FiberCore's human agents. This lets them focus their expertise and, importantly, their empathy on more complex, high-value, or emotionally nuanced interactions that genuinely need human judgment. This shift can lead to more engaging and fulfilling work for employees, potentially reducing burnout and boosting overall job satisfaction.
Letting humans do the human stuff. What about C, scalability?
Absolutely key for a growing company like FiberColt. A chatbot offers exceptional scalability. It can easily handle increased customer demand without needing a proportional increase in human staff. This gives them a flexible and cost-effective way to manage fluctuating customer interaction volumes and expand service capacity without hitting hiring constraints.
And finally, D, cost savings, the classic driver.
Right. Automating a substantial chunk of routine customer service can lead to considerable reductions in operational costs. We're talking expenses related to staffing, extensive training for new agents, the infrastructure needed for large traditional call centers. These savings can then be reinvested into other strategic areas or just directly contribute to the company's bottom line.
What's particularly insightful here, I think, is that AI's value isn't solely about cutting costs, as you said. It can genuinely elevate employee satisfaction by letting humans focus on what they do best, complex problem-solving, empathetic interaction, while the AI efficiently handles the repetitive stuff. It's a classic example of a win-win scenario if it's implemented thoughtfully, optimizing both operational efficiency and the human element of service. Okay, let's transition now to Chapter 2. Here, we take a deeper look at some of those pressing concerns in AI today. We'll explore how to effectively address bias that might, contaminate models, how to ensure accuracy even when the underlying data changes over time, that drift issue we touched on, and how to rigorously secure these increasingly powerful systems, especially with the recent explosion of generative AI.
Yeah, these are undeniably critical areas for any organization deploying AI, absolutely essential.
Our first question for this chapter is, which of the following would best address statistical bias in AI solution outputs that show statistical bias against certain demographics? The options again. A. Examine the AI solution's algorithms for errors. B. Reevaluate the ethical implications of the initial design. C. Boost the computational power of the AI solution. Or D. Enhance the diversity of the training dataset. When you consider where that statistical bias most fundamentally comes from within an AI system, which action goes straight to the heart of the problem?
The most effective approach here, the one that directly targets the root cause of statistical bias, is definitely D. Enhance the diversity of the training data set. This is really a fundamental truth in AI. If the training data used to teach the AI doesn't adequately represent all demographics, maybe certain groups are significantly over or underrepresented, or if the data itself reflects historical societal biases and inequities, then the AI is going to learn from this skewed perspective. When it then makes predictions or decisions, it will inevitably perpetuate those biases in its outputs. By actively making the training data more diverse, more balanced, and truly representative of the real-world population the AI is intended to serve, you are, at its very foundation, giving the AI a more balanced and equitable view of the world. This is the primary, the most direct action towards mitigating those biased outcomes that show up as statistical bias against specific demographic groups.
That really clarifies the directness of that solution. What makes the other options less effective for this specific problem of statistical bias, even if some are general good practices? A. Examining algorithms for errors.
Well, examining algorithms for errors is crucial for general model performance and debugging, no doubt. However, an algorithm can be perfectly functional, technically correct, and still produce biased results if it's fed biased data. The algorithm is simply learning the patterns present in the data, even if those patterns are inherently unfair. It's usually the data, not necessarily the code itself, that holds the bias in these cases.
Right. The code does what it's told with the data it gets. Okay, B. Reevaluate ethical implications of initial design. That sounds important, but maybe too late.
It is extremely important, and it should be an integral part of the AI development lifecycle right from the very beginning to help prevent bias. But once bias is already showing up in the outputs, you need a specific corrective action to address the existing problem. Reevaluation might inform future preventative measures, absolutely, but it doesn't directly fix the current biased outputs.
Gotcha. And C. Boosting computational power just makes it faster at being biased.
Pretty much, yeah. More computational power has no direct bearing on reducing bias. It simply allows the AI to process and learn from the existing data faster, including any biases contained within that data. It won't magically make the data more diverse or fairer, it just processes biased information with greater speed.
This really emphasizes again that understanding AI isn't just about the code or the raw processing power, it's profoundly about the data it learns from. Data quality, diversity, genuine representation, these are paramount for building ethical and fair AI systems. And this is just a core principle for any effective AI audit you might encounter. Okay, next we address a vital aspect of keeping AI performance and reliability up over time. The question: which component should be included in an organization's change management program to maintain the accuracy of artificial intelligence, AI outputs, when data changes occur? Your options: A, establishing robust data drift monitoring mechanisms. B, monitoring data lineage and model training. C, training AI models periodically with minimal testing. Or D, implementing comprehensive hardware upgrades. Think about the inherently dynamic nature of real-world data, right? And how that constant flux can impact an AI model that was trained on a specific snapshot of past information. What do you need?
The answer that most directly and effectively addresses maintaining accuracy when that data changes is A, establishing robust data drift monitoring mechanisms. Yeah, AI models are initially trained on historical data, but the real world, as you said, is constantly in motion. Data drift refers to significant changes in the statistical properties of the input data, or maybe alterations in the relationship between input and output variables as time goes on. For example, consumer buying patterns might shift, economic indicators could change completely, new types of cyber threats might emerge, you name it. If the data that an AI model processes in its live production environment starts to differ significantly from the data it was originally trained on, its accuracy and its relevance will inevitably degrade, sometimes rapidly. Robust data drift monitoring mechanisms allow an organization to detect these subtle or sometimes overt changes early on, analyze their impact, and then make timely adjustments. That might mean retraining the model with fresh data, recalibrating its parameters, maybe even redesigning certain components to maintain its optimal performance and continued functionality. It's basically an ongoing health check, ensuring the AI continuously understands its evolving operational environment.
That's a great analogy, like checking the pulse of your AI system, making sure it's still accurately interpreting the world around it. So, what makes the other choices less suitable for addressing this specific problem of accuracy degradation because the data changed? B, monitoring data lineage.
Monitoring data lineage focuses on understanding the origin, transformations, and flow of data from its source right through to its use in model training. It's crucial for data governance, traceability, debugging, but it doesn't specifically focus on detecting changes in data patterns over time that happen after the model has been trained and deployed. Those changes affect its accuracy in a live production environment.
Okay, different purpose. And C, training periodically with minimal testing. That sounds risky.
Oh, it's not just risky, it could be genuinely detrimental. While periodic retraining is often necessary to combat data drift, doing so with minimal testing would significantly increase the risk of deploying inaccurate, unstable, or even harmful models into production. Robust testing after any retraining is absolutely paramount for system integrity.
Yeah, that sounds like a recipe for disaster. Okay, D, implementing hardware upgrades. Faster, but not smarter.
Exactly. Hardware upgrades might certainly improve the speed or processing capacity of the AI system, allowing it to handle larger volumes of data faster or run more complex models. However, hardware upgrades alone won't directly address accuracy issues caused by fundamental changes in the nature of the input data itself. You could have the fastest computer in the world, but if it's fed irrelevant or fundamentally changed data, its outputs will still be inaccurate.
This really underscores a critical point for you to consider. AI isn't some static product that you just set and forget. Not at all. It's a living, breathing system that demands continuous attention, monitoring, and adaptation, particularly as its environment, the data it processes, constantly evolves. Ignoring data drift is kind of like trying to navigate a rapidly changing city with an outdated map. You're just bound to get lost, and your AI will certainly lose its way. Okay, this next question is exceptionally relevant, I think, given the explosive rise and widespread adoption of generative AI, particularly large language models like ChatGPT and others. The question is, which of the following would best improve the security of an enterprise's generative AI, GenAI models, against prompt injections? Your choices. A, implementing robust access controls on data sources. B, regularly updating the AI model's algorithms and parameters. C, using templates for input structuring and sanitization. Or D, enforcing endpoint security measures for AI systems. Consider the unique attack vector that prompt injection represents. How does it differ from more, let's say, traditional security concerns, and what targeted defense really addresses it head-on?
The most effective method specifically for combating prompt injections is C, using templates for input structuring and sanitization. Yeah, prompt injection is a relatively new and, frankly, quite sophisticated type of attack. It's where malicious instructions or adversarial data are cleverly inserted into a user's prompt, that's the text input giving to a Gen AI model, with the specific aim of manipulating the model's behavior. This can lead the AI to bypass its intended safety guardrails, potentially reveal confidential training data it shouldn't, or perform actions completely unintended by its designers. It's like tricking the AI. By implementing templates for input structuring, you can predefine the expected format and content of inputs. This significantly limits an attacker's ability to just introduce arbitrary, harmful text. Furthermore, robust sanitization processes can actively clean, filter, or validate unexpected or malicious elements within the input before they even reach the core model for processing. This layered approach creates a powerful protective barrier. It standardizes the flow of information and substantially reduces the attack surface for prompt injections by preventing malicious code or instructions from being interpreted by the model as legitimate requests.
This really highlights how specific the solutions need to be for such a unique AI vulnerability. Why are the other options less effective for this particular issue of prompt injection? A. Access controls on data sources.
Access controls on data sources are absolutely critical, but for protecting the training data that initially builds the AI model's knowledge base. Prompt injection happens at the inference stage. That's when users interact with the already deployed model, not during data sourcing or training. The attacker isn't trying to access the raw data. They are trying to manipulate the model's live behavior through its input channel.
Okay, different stage of the process. B. Regularly updating algorithms and parameters. That sounds like good hygiene generally.
It is. It's sound general security practice for enhancing overall model performance, stability, and security over time. As new vulnerabilities are found or new defense mechanisms develop, updates are vital. But it's a broad security improvement. It's not a direct or immediate defense against a live prompt injection attack that specifically exploits the model's input interpretation capabilities.
Right. And D. Enforcing endpoint security. Protecting the server itself.
Crucial, yes, for the overall security posture of the system's underlying infrastructure, protecting the servers, networks, machines where the AI runs. However, prompt injection operates at the application layer. It manipulates the prompt itself. An attacker doesn't necessarily need to breach the endpoint security to inject a prompt. They just need a legitimate or seemingly legitimate way to submit text to the AI. This specific attack often bypasses typical network or host-level endpoint defenses.
So what does this tell us about managing the unique vulnerabilities inherent in generative AI? It's clear it represents a significant new frontier for security. It demands tailored approaches like meticulous prompt hygiene, stringent input validation, because the very nature of the attack surface has fundamentally shifted to how we actually interact with these intelligent models. Okay, our next case study thrusts us into, well, frankly, a high-stakes manufacturing nightmare. Picture Vincent Motors, a state-of-the-art automobile plant where advanced AI systems control critical robotic welders. This is cutting-edge automation, right?
That's like it.
But suddenly, the AI begins to act erratically. It results in severe weld quality issues, which could lead to structural failures in vehicles, and, even more critically, creates a direct risk to human life by disregarding safety protocols. The IT manager has to immediately shut down the entire production line, ultimately discovers the root cause, and manages to implement a temporary fix to restore limited production. This is a very, very high-impact situation where an AI failure has immediate and severe consequences. First, considering this scenario, which of the following describes the AI-related attack in this situation? Your choices. A. Model theft. B. Prompt injection. C. Data leakage. Or D. Model overfitting. Given the immediate effect, describe the AI acting erratically, seemingly ignoring safety protocols, potentially due to external input. What type of attack best fits this behavior?
Given the erratic and dangerous behavior of the AI, where it specifically ignored safety protocols, the most probable cause, particularly in an industrial setting using instruction-following AI, is almost certainly B, prompt injection. Yeah, as we've just discussed, prompt injection occurs when an attacker manipulates the AI model's behavior by inserting malicious or unintended instructions directly into its input prompt. In a high-stakes industrial environment like Vincent Motors, it's highly probable an attacker sent carefully crafted prompts designed to, for instance, unilaterally increase production speed way beyond safe limits, or maybe covertly alter welding parameters, thereby overriding established safety protocols. This would directly cause the welders to malfunction, produce substandard welds, and most critically, disregard human safety measures. It represents a direct adversarial manipulation of the AI's operational instructions, leading straight to the chaotic and dangerous behavior they observed.
That paints a really vivid and frankly scary picture. And the other options, why wouldn't they typically lead to this kind of specific malicious operational behavior in a live production environment? Model theft, A.
Model theft implies the AI model itself was stolen, copied, maybe exfiltrated. While that's a serious intellectual property breach, absolutely, it doesn't directly explain the malfunctioning behavior of the AI in active operation on the factory floor. The model might be compromised by being stolen, sure, but the immediate effect observed is its behavior.
Okay. Data leakage, C.
Data leakage refers to the unauthorized disclosure of sensitive data. Again, a significant security incident, but it describes information being exfiltrated, not the direct operational manipulation of the model that leads to erratic actions and immediate safety risks.
Right. Different kind of harm. And D, model overfitting.
Model overfitting, as we said, is a training issue. The model performs too well on training data, poorly on new data, because it memorized patterns instead of generalizing. While this can lead to performance degradation, sure, it doesn't explain malicious or intentionally erratic behavior driven by external adversarial input. That's the defining characteristic of a prompt injection attack.
Okay, so once the incident was confirmed and the AI model was isolated, a crucial first step in any incident response, the team wisely disabled the operator dashboard to prevent any further malicious prompts. Smart move. Now, the critical priority is to understand how this happened. Which of the following actions would best help the team identify the cause of the prompt injection? Your options. A, reviewing logs of AI prompts and interactions with the system. B, isolating and segmenting the network for future use. C, sampling training data to identify faulty data. Or D, checking the production line for malfunctions in the equipment. If you were a digital forensic detective on this case, what kind of records would you immediately go to tell you precisely what instructions were given to the AI and when?
The most direct and effective action to pinpoint the cause of a prompt injection is absolutely A, reviewing logs of AI prompts and interactions with the system. Yeah, this is truly the investigative equivalent of following the digital breadcrumbs. These logs would provide a meticulous chronological record of exactly what prompts were submitted to the AI, maybe who submitted them, assuming proper user authentication logging was in place, precisely when they were submitted, and critically, how the system responded to each input. This forensic data directly pinpoints the origin of the malicious prompts, reveals the specific content of the injected command, and crucially, helps the team understand any specific faulty or lacking controls within the AI system or its user interface that allowed the injection to occur. It provides the direct, undeniable evidence of the attack sequence.
That makes perfect sense for finding the smoking gun. Why wouldn't the other options be as effective for identifying the precise cause of this specific prompt injection? B, isolating and segmenting the network. That sounds like containment.
Exactly. It's an absolutely crucial containment and prevention measure. It stops the attack from spreading, secures the environment for the future, limits potential damage. However, it doesn't help you diagnose what specific prompt or vulnerability caused the past incident. It's about future resilience, not past investigation.
Right. C, sampling training data. We already established this is an interaction problem, not a training one.
Correct. Sampling training data would be highly relevant for investigating issues like systemic bias or general model accuracy problems, as we explored earlier. But a prompt injection happens during the interaction phase with the deployed model, not due to inherent flaws in the original training data itself. The training data might have been perfect, but the deployed model got manipulated by external input.
Got it. And D, checking the production line equipment. That's the symptom, not the cause.
Precisely. Checking the production line focuses on the physical equipment, the robotic welders. While the welders were indeed malfunctioning, that was the result or symptom of the AI's erratic behavior, not the cause of the prompt injection into the AI itself. The problem originated in the AI's instructions, not a mechanical failure of the robotics.
Okay, finally, after such a high-impact incident, the IT manager immediately requests an urgent audit to prevent any future occurrences. Makes sense. Based on this incident and best practices in AI security and governance, what are some of the key areas the auditor should recommend for this comprehensive audit? This is an open-ended question for us to think about.
Yeah, given the critical nature of this incident, with direct risks to human life and production, an auditor should definitely recommend focusing on several key and interconnected areas for a thorough audit. First, access controls. This is paramount. The audit must rigorously review who has access to AI control systems, operator dashboards, all related networks. It's crucial to ensure the principle of least privilege is strictly enforced. Users only have the absolute minimum access necessary for their role. Foundational for preventing unauthorized interaction.
Makes sense.
What else? Data management and logging. While prompt injection was the specific attack here, a comprehensive review of the overall data lifecycle is always critical. The audit should ensure the training data set used by the AI is robust, accurate, protected from tampering. Crucially, it must also rigorously review how interaction data, specifically logs of prompts and responses, is stored, secured, retained, and made readily available for forensic analysis in case of future incidents. You need that audit trail.
Okay. Given the safety aspect.
Absolutely. Safety overrides and human-AI interaction. Given the direct risk to human life, the audit must explicitly examine how the AI's decision-making process interacts with and impacts safety protocols. Were safety guidelines overridden? Can the AI be commanded to exceed safe operating limits? This needs a deep dive into the AI's built-in guardrails, fail-safes, emergency shutdown procedures, and also the design of the human-AI interface itself.
And the people involved.
Right. Training and awareness. It's vital to assess whether operators, plant managers, floor staff are adequately trained on the safe and proper use of the AI system. This includes how to identify abnormal behavior, potential manipulations, and effective response protocols in emergencies. User awareness is a critical, often overlooked line of defense.
Good point. And finally, addressing the specific attack.
Exactly. Input validation and standardization techniques. This directly addresses the identified attack vector. The audit should specifically assess if the organization is implementing robust techniques like prompt templates, input sanitization, strict validation to mitigate prompt injections. Are there controls in place to scrutinize and filter user inputs, preventing arbitrary or malicious instructions from reaching the core AI model?
That's a truly comprehensive list. It clearly illustrates that an AI audit isn't merely about technical checks or finding isolated security bugs. It profoundly involves crucial considerations like the human element through training, robust processes like access controls and standardization, and the deep ethical implications, especially when human lives are literally at stake, like in a manufacturing plant. This holistic perspective is just absolutely critical for you to consider in any AI deployment, especially high-risk ones. All right, let's bring our deep dive towards a close with Chapter 3. This takes us into specific high-stakes applications of AI. We'll examine how the fundamental principles we've been discussing apply across distinct but equally crucial domains, from ensuring fairness and accuracy in medical diagnoses to significantly improving efficiency and control in financial reporting.
Yeah, these are definitely areas where AI's impact is not just considerable, but also inherently sensitive. Lots at stake.
Okay, our first question for this final chapter focuses on a particularly sensitive application. In an audit of an artificial intelligence AI system used for medical diagnostic applications, which sampling method is most appropriate for ensuring that the training data is a good representation of the intended deployment population? Your choices: A, stratified sampling; B, systematic sampling; C, random sampling; or D, judgmental sampling. When you're dealing with diverse patient populations and the critical importance of accurate health outcomes for everyone, what method allows you to ensure fairness and accuracy across all the different groups?
Okay, the most appropriate method for medical diagnostic AI, particularly when the goal is to ensure truly representative training data, is A, stratified sampling. This method is absolutely essential when we're dealing with sensitive, high-impact applications like healthcare. Stratified sampling involves meticulously dividing the entire population into relevant subgroups, often called strata, based on shared and frequently critical characteristics. In a medical context, these strata could be defined by factors like age groups, gender, ethnicity, specific pre-existing medical conditions, maybe disease severity, or even socioeconomic factors that could potentially influence health outcomes or diagnostic accuracy. Once these distinct strata are defined, samples are then drawn proportionally from each subgroup. This deliberate process actively ensures that all pertinent characteristics of the diverse patient population are adequately represented in the AI's training data. This proactive effort to ensure balanced representation is key to preventing biases and significantly improving the AI's accuracy, its fairness, and ultimately its trustworthiness and efficacy for every patient, regardless of their demographic or specific medical profile. Without this approach, an AI might perform brilliantly for the majority, but could potentially fail catastrophically or be discriminatory for underrepresented groups. That's just unacceptable in medicine.
That's a really powerful explanation of why it's so crucial, particularly for medical AI. Why aren't the other options as suitable, even if some might seem simpler on the surface? Systematic sampling, B.
Systematic sampling involves selecting every nth element from a list or sequence. While it's straightforward and efficient, it carries the inherent risk of inadvertently missing specific, potentially critical subgroups if their distribution happens to align unfavorably with the chosen interval. In medical diagnostics, where rare conditions or nuanced demographic responses are vital, missing these could lead to serious diagnostic gaps.
Okay. Random sampling, C. Seems fair, but maybe not representative enough.
Exactly. Random sampling selects elements purely by chance. Every individual has an equal probability of being chosen. While it offers statistical validity for large, truly homogeneous populations, it doesn't guarantee adequate representation of smaller but important subgroups within a diverse population, especially if those subgroups are statistically rare. For example, a purely random sample might accidentally exclude or severely underrepresent a specific ethnic group or a rare disease, which could lead to a biased or ineffective model for those particular patients.
And judgmental sampling, D, relies on expert opinion.
Right. Judgmental sampling relies on the auditor's or expert's discretion and subjective expertise to select data points. While expert judgment is valuable, this method fundamentally introduces subjectivity and can easily lead to unconscious biases in the sample selection process. It might fail to comprehensively cover the true diversity within the target demographics. In a medical context where diagnostic accuracy directly impacts human lives, this approach could introduce severe, potentially life-threatening biases. You need objective rigor.
This truly highlights the profound impact not just of data quality, but more specifically the method of data sampling in these sensitive fields. In areas like healthcare, the ethical and safety implications basically dictate that you must actively and intelligently ensure balanced and representative data. Simply relying on randomness or convenience is just not sufficient. It's not good enough. Okay, next question, shifting our focus back to the audit domain itself. Which of the following would help integrate the use of artificial intelligence, AI, into audit processing and reporting? Your options. A. Create a centralized database for audit results. B. Ensure manual audits cover high-risk areas. C. Allocate audit responsibilities according to team skills. Or D. Implement automated reporting systems. Think about where AI can provide the most immediate and tangible value within the actual workflow of an audit, especially concerning efficiency and generating insights for stakeholders.
The most effective answer for integrating AI into the core processes of audit processing and reporting is D. Implement automated reporting systems. Yeah, while AI certainly has the potential to assist in various audit tasks like anomaly detection, massive data sets, or predicting potential risks, implementing automated reporting systems specifically leverages AI's capabilities to efficiently process huge volumes of complex audit data. It allows AI to identify subtle patterns or trends that human auditors might easily miss, and then generate timely, accurate, and often profoundly insightful reports. This directly integrates AI's power into the final stages of the audit process, significantly enhancing both the efficiency of report generation and the depth and scope of the insights that can be presented. AI can distill complex findings into clear, actionable reports, allowing human auditors to focus their valuable time on analysis, strategic recommendations, high-value judgment, rather than on manual data compilation and presentation.
That makes a compelling case for efficiency gains right there. Why are the other options less about integrating AI directly into this specific process of processing and reporting? A. Centralized database.
Creating a centralized database is an excellent practice for data management, ensuring consistency, accessibility across audit teams. But it's primarily an infrastructure improvement. It doesn't inherently integrate AI into the actual processing or reporting workflow itself. It provides the data for AI to use, sure, but doesn't define AI's active role within the process.
Okay. B. Manual audits covering high-risk areas. That sounds like good practice, but not AI integration.
Exactly. It describes a very sound audit practice, aligns with risk-based auditing. But it's fundamentally about human effort and decision-making for targeting resources, not the integration of AI into the work itself. AI might help identify those high-risk areas, perhaps, but this option speaks to the manual follow-up.
Right. And C. Allocating responsibilities by skills. Good management, but not tech integration.
Precisely. Also a very good practice for effective team management, optimizing human resources within an audit department. But it doesn't speak to leveraging AI for the audit work itself or how AI is incorporated into the actual audit processes or outputs. It's about organizing people, not integrating technology into the workflow.
So what does this tell us about the evolving landscape of auditing? AI integration isn't just about crunching numbers faster or maybe identifying potential fraud. It's about fundamentally transforming the entire workflow, from sophisticated data analysis right through to the efficient and insightful presentation of findings. This makes the whole audit process more dynamic, more comprehensive, and ultimately more impactful. It's fundamentally changing how auditors work. Third question, now squarely in the financial domain. Which of the following would best provide insight into how controls related to an artificial intelligence AI solution designed to aid in financial reporting are performing? Options: A. Results of an ethical assessment. B. AI development lifecycle documentation. C. AI metrics dashboards. Or D. Documentation on recent AI privacy and security assessments. When you need to know, ideally in real time, if an AI system supporting something as critical as financial reporting is reliably doing its job, what's your most direct and actionable window into its ongoing performance?
The most effective option for getting immediate and ongoing insight into control performance for an AI system involved in financial reporting is C. AI metrics dashboards. Yeah, the compelling aspect of metrics dashboards is their ability to provide a real-time, consolidated, and often highly visual view of key performance indicators, KPIs, and key risk indicators, KIIs, for the AI solution. For financial reporting, this means you can instantly see if the AI is consistently meeting its accuracy targets for, say, reconciliations, if anomalies are being detected in transactional data, if there are any deviations from expected financial outcomes, or maybe if suspicious patterns are starting to emerge. All of these metrics are direct indicators of how effectively the underlying controls, both technical and operational, are functioning. It truly serves as the ultimate feedback loop, offering continuous visibility and enabling immediate intervention if performance deviates from expectations or if any controls appear to be weakening.
That definitely sounds like the most actionable approach. Why wouldn't the other options, while important in their own right, provide the best insight into ongoing control performance? A. Ethical assessment results.
Ethical assessments are vital, absolutely, during the design phase and for ensuring ongoing compliance with ethical guidelines. They tell you if the AI should be doing something and if it's designed fairly and responsibly. But they don't directly show the ongoing operational performance of the controls that ensure accuracy and integrity in live financial reporting.
Okay. B. AI development lifecycle documentation. That's about the past.
Exactly. It tells you how the AI was designed, built, tested. Crucial for understanding the system's architecture, its history, design decisions. However, it doesn't provide real-time insight into how it's currently performing in a live production environment under current dynamic conditions. It's a static record, not a dynamic performance monitor.
Makes sense. And D. Privacy and security assessments. Important, but maybe too narrow for performance.
Right. They focus on compliance with specific regulations like GDPR, CCPA, and identifying security vulnerabilities. Absolutely necessary for the overall integrity and trustworthiness of the system. But a dedicated AI metrics dashboard offers a broader, real-time picture of overall control effectiveness and AI performance related to its core function in financial reporting, which extends beyond just privacy and security compliance checks.
So when it comes to ensuring trust and transparency in AI-driven financial decisions, metrics dashboards are really your essential real-time window into reliability, accuracy, and overall control effectiveness. In a domain where precision and trust are just paramount, having immediate continuous insight into how your AI is performing is basically non-negotiable.
Okay, our final case study introduces us to Moon Capital. They're a financial services organization that's enthusiastically embracing AI across its operations, banking, treasury, investing, the works. Their chief audit officer, CAO, is keen to leverage AI to significantly improve current audit workflows, specifically targeting the often tedious manual reconciliation checks performed at the end of each month. Ah, yes, the month-end reconciliation headache, a common pain point for many financial institutions, often prone to human error and just eats up so much time.
Right. So first for Moon Capital. Which of the following options could best address the business problem the CAO is looking to solve with an AI solution?
Yep.
Choices. A. An AI assistant to create interview questions for accounts receivable teams. B. A large language model to aid in analyzing data for end-of-month checks. C. A generative AI solution to create templates for audit finding reports. Or D. Automated log collection to test for latent machine learning algorithm. Consider the core task here, analyzing vast amounts of diverse financial data, looking for discrepancies. Which type of AI really excels at that kind of complex information processing and comparison?
The most appropriate solution for aiding those month-end reconciliation checks, which often involve really complex data analysis and comparison, is B, a large language model to aid in analyzing data for end-of-month checks. Yeah, reconciliation is a process that demands meticulous processing and analysis of immense quantities of financial data, often originating from disparate sources, existing in various formats: structured ledgers, spreadsheets, unstructured invoices, bank statements, transaction logs. It's a mix. Large language models, LLMs, are uniquely suited for this. They excel at rapidly understanding, extracting, synthesizing, and comparing information from diverse text and numerical data. This powerful capability makes them exceptionally effective for quickly sifting through countless transaction records, identifying subtle discrepancies, confirming balances, flagging anomalies that might indicate errors or potential fraud during those intensive month-end checks. They can parse natural language descriptions found in ledger entries just as easily as they can process structured numerical data. It provides a highly versatile and powerful tool for this often complex and very labor-intensive task.
That makes a really compelling case for LLMs here. Why aren't the other options as optimal for reconciliation specifically? A, AI assistant for interview questions.
That's certainly a valid and potentially useful AI application within an organization, sure, but it's not directly focused on the core task of data analysis and matching in the reconciliation process. It's more of an HR or maybe audit planning tool.
Right. C, generative AI for report templates. That's later in the process.
Exactly. It focuses on report generation, which comes after the reconciliation and audit findings have been established. It improves the output or documentation phase of the audit process, not the core analytical process of reconciliation itself.
Got it. And D, automated log collection. That sounds very technical.
It is. It's geared towards debugging, performance monitoring, maybe identifying hidden patterns within a deployed AI system. It's a highly technical task relevant to AI system maintenance and security, not the core business problem of reconciling financial accounts for discrepancies.
Okay, so after selecting an LLM, the Moon Capital team understandably expresses concerns about getting enough high-quality training data and, importantly, the considerable effort often needed to prepare it. That can be massive for an LLM. What data collection methods should the CAO recommend, keeping in mind both practical efficiency and those crucial safeguards we've talked about?
Yeah, that's a valid concern. For an LLM in this context aimed at financial reconciliation, the CAO should really recommend a multifaceted approach to data collection, emphasizing both efficiency and, crucially, robust safeguards. First, data scraping. This technique can be incredibly useful for systematically extracting both structured data from internal databases, existing spreadsheets, financial systems, and unstructured data from past financial reports, contracts, emails, previous audit documentation that are relevant to reconciliation. It allows for efficient aggregation of large volumes of info from various internal and external sources.
Okay, scraping makes sense. What else?
Yeah.
Maybe dealing with older formats.
Exactly. Optical character recognition. OCR. In many financial institutions, a significant amount of critical reconciliation documentation, historical invoices, paper bank statements, scanned agreements might still exist in physical or image format. OCR tech is essential here. It can convert these image-based documents into digital, editable, machine-readable text, making them accessible for the LM to actually process and analyze.
Crucial for older records.
Yeah.
And the safeguards.
Absolutely paramount. Ethical, legal, and privacy considerations. The CAO must emphatically stress that all data collection must meticulously adhere to strict ethical guidelines, robust legal requirements like data retention laws, anti-money laundering regs, financial reporting standards, and comprehensive privacy regulations like GDPR, CCPA, and industry-specific financial privacy laws like GLBA in the U.S. Data should be anonymized or de-identified wherever appropriate and technically feasible, and stringent access controls and security measures must be in place to protect sensitive financial and customer information throughout the entire lifecycle: collection, storage, processing. This isn't just a technical challenge, it's a compliance, ethical, and trust challenge of the highest order.
This truly highlights that data collection, particularly for powerful tools like LLMs in sensitive domains like finance, transcends mere technical execution. It becomes a really complex legal and ethical landscape, if not handled with the utmost care, foresight, and responsibility. It's fundamentally about data stewardship as much as it is about data acquisition. Okay, if Moon Capital's audit teams are going to effectively use this new AI solution, they'll certainly need a robust training program. That's a given. What key areas should be included in their training to ensure they can leverage the AI responsibly and accurately interpret its outputs? Options: A. Data management procedures. B. Bias and fairness considerations. C. Overview of large language models. D. Coding practices. When you think about what an auditor truly needs to know to be competent and responsible when integrating a powerful AI tool like an LLM into their work, which of these are just non-negotiables?
Okay, I'd say options A, B, and C are all absolutely essential for the audit team's training to effectively and responsibly use the new AI solution. Option D, coding practices, is generally less critical for auditors in this specific context.
All right, let's break that down. A. Data management procedures. Why is that key for auditors?
Auditors really need a solid understanding of how the data used by and generated by the AI solution is classified, securely stored, retained, and eventually disposed of. This ensures the ethical and compliant use of sensitive financial data. It also helps auditors effectively trace information for their reviews, ensuring data integrity throughout its lifecycle. They need to understand the data's journey and its trustworthiness.
Makes sense. B. Bias and fairness considerations. We've talked a lot about that.
Crucial. Understanding how biases can subtly or overtly creep into AI models, especially LLMs, how to identify potential bias in AI-driven insights or recommendations, and how to effectively mitigate these biases is absolutely crucial for conducting fair, accurate, and ethical audits. Auditors must be equipped to critically evaluate AI outputs for any unintended discrimination or skewed results that could impact financial decisions or reporting.
Okay. And C. Overview of large language models. Just knowing what it is.
A general conceptual understanding, yeah. What LLMs are, how they function at a high level, their inherent capabilities like text generation, summarization, pattern recognition, and vitally, their limitations and potential pitfalls. Things like the tendency to hallucinate or their reliance on biases present in their training data. This will help auditors effectively leverage the tool, critically interpret its outputs, and understand where human oversight is most critical.
Right. Knowing its strengths and weaknesses. So why not D? Coding practices.
Well, while understanding coding can be incredibly useful for the AI developers and engineers who build these systems, auditors are generally not expected to engage in the actual coding or development of the AI itself. Their primary role is to audit its use, its performance, its governance, not necessarily its underlying code line by line. Therefore, extensive coding practices are typically less directly relevant for their operational training in this role.
This really brings home the point, I think, that AI auditors increasingly need to be multidisciplinary. It's no longer just about traditional auditing techniques. It's about deeply understanding the technology, recognizing its inherent biases, knowing how to manage the vast amounts of data underpinning it, and skillfully interpreting its complex outputs. This holistic skill set, blending technical literacy with traditional audit acumen, is clearly the future of the profession. Okay, finally, after all this analysis and reconciliation using the new AI, the audit team needs to effectively report on the performance of the AI solution and its impact on the reconciliation process. They need to show this to various stakeholders. Which of the following is the best tool for the audit team to use to generate visualizations to report on the performance of the AI solution? Your choices: A. Excel spreadsheets, B. Tableau, C. ChatGPT, Confluence. When your goal is to transform complex data into something easily understandable, interactive, and visually compelling for decision makers, what's the industry's kind of go-to solution?
The best tool for generating robust, professional data visualizations in this scenario is definitely B, Tableau. Yeah, Tableau stands as a powerful, industry-leading business intelligence, or BI, and data visualization tool. It is purpose-built, specifically designed for processing large amounts of diverse data, performing complex analyses, and then creating highly interactive, dynamic, and extensively customizable data visualizations. It excels at taking complex data sets like AI performance metrics, reconciliation discrepancies, comprehensive audit findings, and transforming them into easily understandable charts, graphs, interactive dashboards. This is precisely what an audit team needs to effectively communicate AI performance and findings to various stakeholders, allowing them to explore the underlying data themselves and grasp critical insights quickly and intuitively.
That truly highlights why a specialized tool is necessary here. And why aren't the others, despite being widely used for other things, the optimal choice for this specific task? Excel, A.
Excel spreadsheets are fantastic for basic data entry, calculations, simple charts for small data sets. We all use them. But they quickly become unwieldy and limited when dealing with the large, complex data sets common in AI performance monitoring, or when you need the interactive, dynamic visualizations that dedicated modern BI tools provide. They just lack the scalability and sophisticated visual capabilities required for comprehensive reporting here.
Okay. ChatGPT, C. Can it make charts?
Well, ChatGPT is a large language model designed for conversational AI, generating human-like text responses. While it can answer questions about data if you prompt it correctly, it is fundamentally not a tool for generating robust, interactive, or visually rich data visualizations in the way a dedicated business intelligence tool like Tableau is.
Got it. And D, Confluence. That's more for collaboration.
It's exactly. Confluence is a collaboration and knowledge management tool often used for documentation, project planning, team workspaces. While you might embed visualizations created by another tool, like Tableau, into a Confluence page, Confluence itself is not a data visualization tool. It's where you might publish or share your reports, not what you use to create the actual graphs and dashboards.
So, for you, the learner, the clear message is this. The right tools make all the difference in clearly and effectively communicating complex AI audit findings. In a world increasingly driven by data and its intelligent interpretation, the ability to visualize that data compellingly and comprehensively is just as crucial as the analysis itself. Hashtag tag outro. Wow, what an extensive deep dive that was. We've meticulously unpacked, well, everything from the high-level strategic roles of AI steering committees to understanding the subtle nuances of different types of bias, like that systemic bias example in gender discrimination. We've explored cutting-edge methods to secure generative AI against specific threats like prompt injections, and even looked at how to optimize traditional audit processes with specialized AI solutions and the right visualization tools in really high-stakes fields like finance and medical diagnostics.
We truly hope that walking through these self-assessment questions and these case studies, step by step, has provided you with a much clearer understanding. Not just of the immediate answers, but of the deeper, interconnected principles at play in AI auditing and governance. Our aim was really to help you develop that critical lens, allowing you to evaluate AI in any context, seeing beyond the hype to its practical implications, its inherent risks, and its profound benefits.
I certainly feel I have a much clearer picture now, too. And for you, the learner, our goal was precisely to provide that clarity, those moments of genuine insight that make complex topics just click into place. You've seen how abstract theory translates directly into tangible real-world challenges and innovative solutions, from a chatbot improving customer service in telecoms to an AI welder on a factory floor with literal life or death implications, and how crucial financial audits are fundamentally evolving. It's about building that foundational knowledge that can continuously adapt as AI keeps emerging.
Which brings us to a compelling thought as we wrap up. As AI continues to integrate even deeper into every facet of our lives and work, becoming more autonomous, more pervasive in its capabilities, what entirely new types of biases or security vulnerabilities might emerge that we haven't even begun to conceive of yet? And maybe more importantly, how will our fundamental understanding of auditing, and indeed of responsible governance and ethical implementation, need to continually adapt and expand, not just to keep pace with these rapid advancements, but to proactively ensure that innovation is always coupled with robust responsibility and effective control?
Those are exactly the kinds of questions that keep us learning. That's precisely why we love these deep dives. Thank you so much for joining us on this insightful exploration. Keep asking those critical questions, keep being curious, and we'll catch you on the next deep dive.